So today we are starting Unit 5, and we are looking at Unit 5 is solving systems of equations. Today's notes are solve systems from a graph. So this is the most basic way to solve a system of equations, and we'll talk about our learning targets and then how to solve from a graph that has been given. Our learning targets today are that we will be able to define a solution in terms of a system, that we will be able to identify whether a system has a solution from a given graph, and that we will be able to identify the number of solutions to a system given a graph. All right. So first of all, we want to define what a system is. So a system is basically a collection of two or more equations involving the same set of variables. So a related event, two related events or more related events happening at the same time, using the same variables. And then when we graph them on the same coordinate plane so that we can see how they interact together. So a system is a collection of two or more equations involving the same set of variables. Graphed on the same coordinate plane. Okay, and then a solution to a system is the values, excuse me, the values for each variable that work in all equations in the system. Okay, so the values, which is going to be coordinate pairs for each variable that satisfy or make true all equations in the system. Okay, so in this graph, we have a parabola, which is this curved figure on the graph, and then we have a line. So the 2 points at which the parabola and the line intersect are the solutions of the system. Okay, so the first solution is 2, -3. And well, it's not first or second, it's kind of arbitrary, but the other solution is -3, -8. Okay, and then when we plug these these points into both equations, it'll make both equations true. Okay, so y equals x minus 5 and y equals -x² + 1. When I substitute in these values, it makes it's true for both equations. Okay, and in order to be a solution of the system, it has to be true for both, since we have two, or all when you have three or more of the equations in the system. Okay, so then next the question is, let me adjust my camera here. How many solutions does the above system have? And then explain. So it has two solutions, so 2 points of intersection. So the system has two solutions. Okay, and then it's because the graph intersects in two places, or the two graphs, we'll say functions, intersect in two places. Okay, and our solutions are -3, -8, and 2, -3. So we have two solutions for that system. All right, let's head over to page 2. All right, and next we are asked to determine if each system has solutions or not. If the system does have a solution or solutions, then determine how many solutions it has and approximate the solutions. Okay, so here, this point is a solution. So we have two functions graphed, okay, here and here. So they intersect in 1, 2 places. All right, so this I would say is about, let's see, -1, 2, 3, 4, -5.2 approximately, and 1, 2, maybe 2.9. And this solution I would say is 1, 2, and then negative maybe 1.1. So 2, -1.1. All right. So those are the two solutions because the two functions intersect twice. Okay, so when I plug these, we don't have the equations for these two functions written out, but if we did, when we plugged in this x, y ordered pair, it would make both equations true. And when we plugged this in to each equation, it would also make the equation true or function. All right, number 3, or actually it's not numbered, but the next example. Okay, so here we have two lines, okay, and they're non-parallel lines, so they will intersect, and they're intersecting right here. Okay, so one solution. Oh, and I didn't write down two solutions here, so I'm just going to add that in, two solutions. This one will have one solution. And then we approximate that solution, so -1, 2, 3, 4, 5, 6 and a half. And then -1. Well, yeah, let's say -0.9. And the two lines intersect in exactly one place. So the two lines intersect in one place. Okay. And actually, if we want to be more mathematically precise, let's say at one point. Okay, so one solution there. All right, and then let's go on to the next page. Okay, so we can get this on the screen. All right, so then these two lines are parallel, so they're not going to intersect ever. Okay, so no solution. Okay, parallel lines never intersect is our explanation. Parallel lines never intersect. Okay, and then let's take a look at the next example. So here we have three different graphs, three different equations that are graphed. In order to have a solution, the point has to be a solution for all three equations. Okay, so let's go ahead and look at the circle. Okay, so I'm just going to follow along the graph of the circle, and here's an intersection between the circle and the parabola, but the line does not intersect there. Okay, moving along, here is an intersection of the line and the circle, but the parabola doesn't intersect. Okay, moving on, here's the circle and the parabola again, but not the line. Okay, moving on, here's another point where the circle and parabola intersect, but not the line, so that's not a solution. And following my circle again, here is the parabola and the circle, their fourth intersection. But again, the line does not go through there, so it's not a complete solution. It's not a solution. And then moving back up, this is where the circle intersects this line for the second time, but the parabola does not intersect there. And then moving back up here to 12 o'clock where we started. Okay, so this has no solution. Okay, and the reason is there are no points at which all three functions intersect. And these aren't functions. Actually. This circle is not a function, so graphs intersect. And remember that circle is not a function because it doesn't pass. This is just a refresher from first semester. The circle is not a function. It doesn't pass the vertical line test. Each input does not have a unique output. So for example, at x equals 0, I have the circle would be here and here. It would have values. Okay, so it's not a function. It's just an equation or relation. Okay, so no solution there. And I chose the circle because I just chose the circle. I could have followed the line or I could have followed the parabola. And I don't need to check all three of them because remember, I'm just looking for any point at which all three equations intersect. So I don't need to check all three. I can just check one of them because if it doesn't work for the circle, it doesn't matter if it works for the other points. So like there's a point of intersection, but it's only the graph and the line in the parabola. Here's another one that's only the line in the parabola. So I don't have to check all three functions. I can just choose one and check that one. Okay. Okay, then moving on to the next. So we have another circle, line, and parabola. Okay, and I do see, so following my circle, that's only two of them intersect, two of them intersect, two intersect, two intersect. Here, all three of them intersect. Okay, so here I do have a solution, and that's at 1, 2, like 3.1, and 1, 2, 3, 4, 5.8 maybe. Okay, and again, we're just approximating. We're not solving these algebraically. Okay, so we have one solution. Okay, there is 1 point at which all three graphs intersect. Okay. And so that is it for solving systems of equations given a graph.